we're going to integrate this integral here using use substitution. So remember, whenever you use substitution, you let the thing inside the composition be your substitution. Now, of course, that doesn't always work, but that is the first thing that you should try when you're working one of these problems. So I'm going to let u equal square root of x, which, of course, is easier to take the derivative of if you write it as x to the 1/2. Then du, which is a derivative, is 1/2 x to the minus 1/2. And if I simplify that, that's du equals 1/2 1 over x to the 1/2 dx. Let me don't forget that. You do need it. Sorry about that. So when you look at this integrand, you can see that it can be separated as 1 over the square root of x cosine square root of x dx. Because remember, if this is cosine over 1 and this is 1 over the square root of x, you just multiply the numerators, you get cosine x. You multiply the denominators, you get the square root of x. So it's the same statement. Now, let's do the substitution. So the square root of x becomes u. 1 over x dx. Well, I have 1 over square root of x dx, but I got this 1/2 involved here. So I'm going to multiply both sides by 2. And then 2 du is 1 over square root of x dx. So that means that 2 du substitutes in for 1 over square root of x dx. Now when you go ahead and just integrate this as is, you get it's plus 2 sine u plus c. I always have to think about that, right? The derivative of sine is cosine, so the integral of cosine is positive sine. Now, since I started with the x's inside the integral, I need to end with x's with my solution. So that's going to equal 2 sine of square root of x plus c, because u is square root of x, so u is the square root of x. And I believe I am done with that problem.